This is Algebra 2A, Section 2.3, Fitting a Line to Data. Point-slope form is a new format for a linear equation that we're going to do on this lesson. Y equals mx minus x1 plus y1. The m still represents slope. The x1 and the y1 actually represent a point that we would find from the data, and it can be like the point that you use to calculate slope or even any point from the data. Just in case you don't remember the slope formula, I'm going to write that again, but we did write it on the very last section. Y2 minus y1 over x2 minus x1. So, the reason that this format is helpful is you don't always have the y-intercept. This table that you can kind of see down here is a really good example of that. If we're measuring carbon dioxide levels, we would need to know how much carbon dioxide there was in year 0, which would represent the y-intercept in this case. And that's not information we have, so we can use the point slope form instead, just using a data point as a starting value instead of the y-intercept of 0 for x. So I'll show you what I mean with a couple examples. Here I have 2 points, 10, 6, 6, 14. I'm going to substitute those values into the slope formula to get the slope and into the x1 and y1 to get the whole equation. So we'll start with m. Okay, try that again. Okay. M equals y2 minus y1, 14 minus 6, over x2 minus x1, 6 minus 10. 14 minus 6 is 8. 6 minus 10 is -4. 8 over -4 is -2. So I have the slope. I can plug that, as well as the x1 and the y1 values into my equation. So that'll be y equals -2 for the slope, x minus 10 for x1, and plus 6 for y1. And that is my finished equation. I'm going to do one more example, same thing, just using a larger data pool. Letter B talks about the CO2 concentration on the top of a volcano. We're going to let years represent the x and carbon dioxide represent the y. And I have 1, 2, 3, 4, 5, 6, a whole bunch of points to choose from. When selecting my x1 and y1, I always want to choose the first. I'm trying to make it fit on the screen. Hold on, let's erase that. Okay, we need to go. There we go, x1 and y1 and x2 and y2. So what I was saying is, we always want to choose the first and the last point in a data set. If you think about making a scatter plot of these, and you know, those first couple points can kind of be anywhere, but as we keep trending over the long run, choosing the first point and the last point usually gives us the best indication of the direction of the line. Not always, but usually. So it's just good practice to choose the first and the last for your points. So I'm going to start with my slope. I have my x's and y's labeled. y2 minus y1 over x2 minus x1. Okay, so we have 37728 minus 33869. The numerator is 3859. bottom looks like 24. So we'll divide that, and we get 1.6 as the slope. So my y equals equation, slope x minus x1 plus y1. Letter B says, use the equation to predict the CO2 concentration in the year 2020. 2020 is a year, that's an x value, so I just want to sub 2020 into the x of the equation. 1.6 2020 minus 1980 plus 33869, and I can just type that. That's an equal, not a z. Type that in the calculator. 1.6 2020 1980 plus 33869, 402.69. So, real world situation. In the year 2020, we predict CO2 concentrations at the top of Mauna Loa volcano to be 402.69 parts per million. I'm going to scroll down to get a little more space for the last one. The question says, when will the CO2 concentration reach 400 parts per million? So I have the same equation here. CO2 concentrations represent the y, so I'm going to put 400 for the y and then solve it. So we have 400 is 1.6 x minus 1980 plus 33869. To begin, we're going to subtract y1 from both sides, so minus I got 6131. Now, with these parentheses, it throws off what we normally do. Normally we would divide by the slope, and that would be our answer. But we're going to have an extra step in there. And so there's a couple different ways to approach it. We could start by dividing by both sides, and then adding both sides at the end. Or we could distribute. I think we're kind of used to distributing, so I'm going to take that approach. I'm going to do 1.6 times x, and that's 1.6x. And then I'm going to do 1.6 times 1980. And that's 3168. So now it kind of looks like another linear equation where we have to add and then divide. So if I add 3168 to both sides, I get a really big number. It's a 9. Sorry, autosave. 3,229.61. And the last step is to divide both sides by the slope. Divide both sides by 1.6. And my answer is 2018. So real world meaning, in the year 2018, CO2 will reach 400 parts per million. Okay, that was a lot of notes. Hope you were able to follow it. Good luck with the exercises, and let me know if you need help.